Very good evening, my dear friends. Good evening, my dear friends. So there is a slight 5 minutes delay is there in the session. So first of all, I would like to welcome you all for the today's MEDISI GTQ session on strength of material. So this course is going to be very useful. आपको सभी को मालूम है पूरा गेट एग्जाम में टेक्निकल सब्जेक्ट्स में स्ट्रेंथ ऑफ मटेरियल वेटेज का ज्यादा रहता है. पूरा टेक्निकल सब्जेक्ट्स में the strength of material weightage is going to be very high. It is almost equal to 50% of the total thermal and total production. कम से कम आपको 10 मार्क मिलेगा. एवरेज आपको 10 से 12 मार्क चाहे 20 में मिलेगा. Some extraordinary cases you are also going up to 14 marks now. So this is minimum 10, maximum is 2. Some extraordinary cases you will go up to 14 marks now. So good evening, my dear friends. There are so many friends are here. Good evening, Shyam Prasad. Good evening, Arun, Bansal. There are so many friends are there. Good evening, Kuldeep, Kumar, Anant. Okay. So for the benefit of the non-MEDISI student, I am S. Krishna. The students have made it as Sm Krishna. I am associated with the MEDISI for almost 2009. I started. Almost 17 years I completed here now. 17 years I completed in the MEDISI now. And overall teaching experience of almost 32 years now. Started in 1994. So this is 2026. So once again, I welcome you all for today's Strength of Material GTQ course for 2026. So this session will take almost 3.5 hours. Because this weightage is more. इसका weightage ज़्यादा रहता है. So this 3.5 hours, I would like to include all the concepts, most of the key concepts of the strength of material is included in this session. I have framed this question. पूरा 25 क्वेश्चन फ्रेम किया था पूरा 10 चैप्टर से. ये पूरा 25 क्वेश्चन पे almost 80% of the key concepts, important concepts of strength of material are included. So before going for the first question, so my suggestion, I am going to display the first question. First step for your success. Assume that now you are answering these questions in the final GATE examination. Since last 1 year अपने prepare कर रहे हैं, so believe in yourself. Assume that a final GATE 2026 SOM questions आप solve कर रहे हैं. मान लीजिए ऐसे. तो पहले क्वेश्चन को ध्यान से पढ़ो, श्रद्धा और ध्यान से पढ़ लीजिए. Try to go through the question properly, understand what is given as the input data, क्या पूछ रहे हैं. This is the first step. Don't be in a hurry. Try to understand the question. Then try to solve the questions with an accurate as well as what now? Speed. आपको सभी को मालूम है गेट इज अ टेस्ट फॉर एक्यूरेसी एंड स्पीड. दोनों चाहिए. एक्यूरेसी चाहिए पहले और स्पीड भी चाहिए. दोनों चाहिए. Once your answer is going to be matched with my answer, automatically your self confidence will increase. आपका आत्मविश्वास बढ़ जाएगा. By chance, if any of the friends आंसर गलत हो जाए तो Please don't demotivated. Don't lose your confidence. Suppose, for example, out of this 25 questions, आपका, for example, worst case I am taking now, आपका 20 questions गलत हो जाए तो, if anybody's questions are 20 questions are incorrect now, please don't be demotivated now. Still time is there, 2 weeks time is there. So meanwhile, if your answer is incorrect, आपका आंसर सही नहीं हो जाए तो फर्स्ट ट्राई टू आइडेंटिफाई वेर यू डन द मिस्टेक नो. आपका गलत आइडेंटिफाई कर दीजिए. देन ट्राई टू रेक्टिफाई योर मिस्टेक. ट्राई टू रेक्टिफाई योर मिस्टेक्स. There are so many reasons for mistakes are likely to be happen. Sometimes lack of concept, lack of substituting the numericals in not proper units. Numerical calculation का गलत होने के chances है. There are so many ways of mistakes are likely to occur. So please try to identify your mistake, do the analysis of your mistakes and try to rectify them. So this is my suggestion. Please don't be demotivated now. Okay. So without wasting the time, I'm coming to the first question. So first I taken the 5 MSQ questions. मैंने पहले MSQ question लिया था. Because in GATE we are having the 3 type of questions: MSQ, MCQ and NEAT. Most of the students, even in the most of the toppers, they are losing the marks in MSQ. Not only students, even some of the faculties are likely to commit a mistake in MSQ. Here more than one answer may be correct. So that's why first I am taking the MSQ question. MSQ question is a test for your concept. Then next they are likely to mistake in the NEAT, numerical answer type. Then MCQ. In MCQ question pe, wherever required, try to use the elimination process. Try to use the elimination process. So this is my advice. So I'm coming to the first MSQ question. The first question states that which of the following statement is or correct. 4 statement दिया था, इसमें अपने which is the statement सही है, which is the statement is correct है, true है, identify करना है. Please go through all this one and give me the answer. First statement क्या दिया था? Bulk modulus is used to determine the change in volume of prismatic bar subjected to pure axial loading. When a bar is subjected to pure axial loading, volume change हो जाता है. So change in volume determine करने के लिए bulk modulus is used. That is the first statement. Under pure torsion, plane strain condition results from plane stress condition and vice versa. Under pure torsion, plane strain condition results from plane stress and vice versa. This is the second statement now. And plane cross sections of a beam remain plane even after simple bending. A question frame करने के लिए almost last 1 week I spent my time now. Plane cross sections of a beam remain plane even after bending. Under pure torsion, shear angle is maximum at a point on the outer surface of the shaft, and angle of twist is maximum at the free end, and is the same for all the points on the cross section. So under pure torsion, shear angle is maximum, the outer surface maximum रहता बोल के दिया था, और angle of twist is maximum at a cross section in the free end, and every point on the cross section दिया था. So now try to give the answer now. 4 statements now. I will check it. How many are given the correct answer now? BCD, BCD, BCD. Everybody is given BCD, CD. Ashutosh Yadav is given CD. And everybody is given BCD, ACD. Okay. So based on this answer, almost 20 students have given the answer. अभी तक कोई भी स्टूडेंट सही आंसर नहीं दिया था. कोई भी स्टूडेंट ने सही आंसर नहीं दिया था. What is the answer for the question now? B and D. B and D. This statement is correct. Everybody is gone for C is also correct now. Most of the students have given the B, C, D. First statement is incorrect. क्यों? Bulk modulus is used to determine the change in volume or volumetric strain under hydrostatic state of stress. Bulk modulus is used to determine the change in volume or volumetric strain under hydrostatic state of stress. But pure axial loading में uniaxial मिलता है. But one student has selected A. So this is incorrect now. Next, why C is incorrect now? Everybody second C the correct now. Plane sections of a beam remain plane even after simple bending. Most of the students बोला था C सही है, C सही नहीं है. C is not the correct statement now. C statement is correct under pure bending. Plane sections remain plane even after bending. That but under which bending? Pure bending. But here क्या दिया था? Simple bending दिया था. This statement is correct when shear force is zero. Bending is a constant. But simple bending बोले तो क्या है? Shear force non-zero है. Bending vary होता है. So this statement is गलत है. So answer for the question is when this C is correct now. This is correct under pure bending. In place of simple bending, pure bending diye to, then C is also correct now. Then when A is correct now, under hydrostatic state of stress, this is correct under but pure axial loading पे आपको uniaxial state of stress मिलेगा. So the answer for the question is B and D. So that's why I'm telling now. Go through the statements properly. ध्यान से सुनिए, श्रद्धार ध्यान से क्वेश्चन को पढ़ लीजिए. Then try to use your concept and try to select the correct answer. Those who are given the incorrect answer, try to identify where you have done the mistake now. Okay. So the answer for the question is B and D. Under pure torsion, sigma x is 0, sigma y 0. When you are going to get about now? When plane stress condition will result the plane strain condition. When plane strain condition results under plane strain condition and vice versa. This statement is correct under pure shear state of stress. So pure torsion पे sigma x plus sigma y 0. So why this statement is correct now? Because pure shear state of stress that is sigma x plus sigma y is 0. तो प्लेन स्ट्रेस कंडीशन पे प्लेन स्ट्रेन कंडीशन मिलना है तो नहीं तो वाइस वर्सा. दिस स्टेटमेंट इज करेक्ट under two conditions. First one is what now? Pure shear state of stress, that is sigma x plus sigma y should be 0. Pure torsion पे sigma x plus sigma y 0. दूसरा कंडीशन क्या है? Poisson's ratio should be 0 होना है. तो plane stress condition leads to plane strain condition and vice versa. This statement is correct under pure shear state of stress and when Poisson's ratio 0. Okay. Okay. So two friends are given. Anirudh is given BD. And Priyansh Raj is also given B and D. Okay. Two friends are given. So initially they are given incorrect, but two friends are given the correct answer now, B and D. Okay. Now, I'm coming for the second MSQ question. Previously क्या दिया था? Which of the statements are true? Here क्या दिया था? Which of the following statements are false है? Is or false? A channel cross section beam, that is the C section, under transfer shear load experience shear force, bendiment and twistment. When a C section channel cross section subjected to transfer shear load, then the cross section experience both shear force, bendiment and twistment. In the absence of axial load, neutral axis of the cross section of a beam coincides with one of the centroidal axis. CA stands for centroidal axis. CA means centroidal axis, not a chartered accountant. Centroidal axis in the plane of the cross section and about which the bending couple or bendiment is acting. तो कभी भी axial load नहीं है तो neutral axis coincide with one of the centroidal axis in the plane of cross section. Plane of cross section में दो centroidal axis रहेगा, एक horizontal centroidal axis रहेगा, एक vertical centroidal axis रहेगा. But it will coincide with HCA or VCA. What is given now? About which bending couple or bendiment is acting. Means if the bending couple is acting about HCA, neutral axis coincide with HCA. If the bending couple is acting about VCA, then it will coincide with VCA. That's the second statement. On two complementary planes, shear stress are equal and unlike in nature and vice versa. दो complementary plane पे shear stress are always equal and unlike and vice versa भी दिया था. What the meaning of vice versa? No? When the shear stress are equal and unlike, they are the complementary plane. Next, material with positive Poisson's ratio exhibit more shear deformation than material with negative Poisson's ratio. Most of the materials are having the positive Poisson's ratio, but कुछ material के लिए positive Poisson's ratio negative होने के chances है. But most of the engineering applications we are dealing with a material with a positive Poisson's ratio. So when the Poisson's ratio is positive, it will exhibit more shear deformation than a material with negative Poisson's ratio. Now we'll check it now. Now which statement is incorrect है? Which statement is incorrect? Saddaman, sorry, sir, C is wrong. Ashutosh Yadav, C and D. Avinash, B and D. ओके so many friends are given. So here wrong statement is C. Wrong statement is C. So this is the answer for the question now. This statement is true. This statement is also true. This is false. This is true. This is true. So if you ask which statements are true, means answer is A, B, D. But is asking false statement. So answer for the question is going to be C. So why the first statement is true? Channel cross section. Channel cross section is what a C section is unsymmetric about VCA. Generally under transfer shear load you are getting shear force and bendiment. Under transfer shear load कब आपको shear force and bendiment मिलेगा? When centroid and shear center coincide हो जाए तो, shear center and centroid coincide हो जाए तो आपको cross section is subjected to only shear force and bendiment. But कब centroid and shear center coincide होता है? When shear center and centroid coincide होता है, when a cross section is symmetric about both the centroidal axis. When a cross section is symmetric about both horizontal centroidal axis, vertical centroidal axis, then shear center and centroid will coincide. Then cross section is subjected to shear force and bendiment. There is no twistement. Example is what now? Circular section, rectangular section, I section. They are all symmetric about HCA and VCA. But if a cross section is not symmetric about HCA and VCA, C section is not symmetric about, it is not symmetric about VCA. It is not symmetric about VCA. It is symmetric about HCA. So here shear center will not coincide with the centroid. Since shear center does not coincide with the centroid, so it is also subjected to twisting moment. So what is the reason for this now? Because shear center does not coincide with the centroid. क्यों shear center centroid से coincide नहीं हो जाता है? Because it is not symmetric about VCA. It is symmetric about only HCA. Next, if the beam is subjected to vertical bending, if the beam is subjected to vertical bending, means these couples are acting in which plane? No, vertical plane. Means about HCA. The neutral axis coincide with HCA. HCA stands for horizontal centroidal axis. If the bending couples are acting in a horizontal plane, horizontal bending, then they are acting about VCA. They are acting what now? Horizontal plane. Means they are acting about VCA. The neutral axis coincide with VCA. So neutral axis coincide with HCA or VCA. Both are possible now. When bending couple or bendiment is acting in vertical plane, neutral axis coincide with HCA. If the bending couple or bendiment is acting in horizontal plane, neutral axis coincide with VCA. But these statements are correct when there is no axial load. Means when axial load मिलेगा under eccentric axial load है. So as long as there is no axial load, so here the neutral axis coincide with either HCA or VCA. So this statement is true. Why this statement is गलत है? Always on two complementary plane. ये दो complementary plane है. इस प्लेन पे shear stress are equal and unlike है. हमेशा दो परपेंडिकुलर प्लेन पे shear stress are equal unlike रहेगा. But vice versa हमेशा valid नहीं है. So whenever the shear stress are equal unlike, they need not be a complementary. First statement is correct, but vice versa is not correct now. Vice versa is not correct. So whenever the shear stress are equal and like, they need not be a complementary. Simple example is what? Planes of pure shear stress. Planes of pure shear stress. On the planes of pure shear stress values are equal, but they are not complementary. They are not complementary. So whenever the shear stress are equal and like, we cannot call that they are complementary planes. So that's why vice versa is not correct now. That's why that's a false. And material with Poisson's ratio is positive. Whenever mu is positive, shear modulus will be less now. When shear modulus less हो जाए तो shear strain ज्यादा रहेगा. shear strain ज्यादा रहे तो shear angle ज्यादा रहेगा. तो कभी भी आपको shear deformation ज्यादा रहना है तो we have to select a material with positive Poisson's ratio. But if the Poisson's ratio negative हो जाए तो क्या हो जाएगा? चेंज इन वॉल्यूम ज्यादा रहेगा. When Poisson's ratio negative हो जाए तो lateral strain and longitudinal strain both are like in nature है. So whenever what a Poisson's ratio negative हो जाए तो longitudinal strain, lateral strains are like in nature. Epsilon V equal to epsilon x plus epsilon y plus epsilon z. All are like in nature है. Then volumetric strain ज्यादा रहेगा. इसीलिए मटेरियल विथ नेगेटिव Poisson's ratio को क्या बोलेगा? Dilatation material. They are exhibiting more change in volume. तो कभी भी change in volume ज्यादा रहना है तो we should select a material with negative Poisson's ratio. आपको shear deformation ज्यादा होना है तो you should select a material with positive Poisson's ratio. So this is the answer for this question now. Okay. We'll come for the next question now. Which of the following statement is or true? Which of the following statements is or true? Thermal stress and longitudinal strain always like in nature. Thermal stress and longitudinal strain always like in nature. Thermal stress is independent of dimensions of a prismatic member. When its thermal deformation restricted either in 1 or 2 or 3 mutual perpendicular directions. Restricted, maybe restricted in 1. Thermal strain and longitudinal strain are always equal unlike in nature है. Thermal strain and longitudinal strains are always equal unlike in nature है. So try to go through the statements properly. Because only in GATE examination, these are the specialty. Remaining all the examination, either MCQ will be there, NAT. But here having the MSQ will be there now. And maximum shear stress in the member is equal to half of the magnitude of the thermal stress. So maximum shear stress in a member is equal to half of the thermal stress दिया था. So out of these 4 statements, which statement is true? Now can you give the answer now? In live chat, try to use your name now. Try to use your name. Don't use the short forms. Don't use the short forms. Don't use your mail IDs. Okay. Try to give your AB, B, Agarwal, Ashutosh Yadav, AB, Avinash, ACD. I hope some of the students are live or my students should be there now. So they should give the correct answer now. Those who have attended my classes online and offline, each and everything I discussed now. Those who have attended my live and offline classes now. So we should give the correct answer now. What the answer they have given now? BB, AD, CD, BD, AB, AB, AB. Okay. So here statements are true. This statement is true. This statement is also true. Some students have selected C and D. It's not correct now. Why this statement is correct now? Incorrect now. Always बोला था. Always बोला था. When this statement is correct now? Under completely restricted deformation. Under completely restricted deformation पे thermal strain and longitudinal strains are equal unlike है. Partially restricted में ये statement नहीं है, सही नहीं है. So when this statement is correct now, in place of always, it is mentioned completely restricted. Completely restricted. If it is mentioned completely restricted, then this statement is correct now. So this statement is correct under completely restricted deformation, but this is mentioned about always. Always बोला तो partially भी हो सकता है. And maximum shear stress in the member is equal to half of the magnitude of the thermal stress. Absolute Tmax is half of the thermal stress. This statement is correct when thermal deformation restricted either in only one direction or restricted in two directions. But when restricted in three directions, this statement is not correct now. When thermal deformation तीनों direction पे restrict करे तो you are going to get a hydrostatic state of stress. Then absolute Tmax is 0. So this statement is correct only when restricted either in one or two. But what is given now? Always. Always बोला था. So this statement is not correct when restricted in three directions. When restricted in three directions. In restricted in three directions, you are going to get a hydrostatic state of stress. That is sigma 1, sigma 2, sigma 3 are equal and unlike in nature hai. Sigma 1, sigma 2, sigma 3 equal and like in nature hai. Then Morse circle will become a point. All the Morse circle will become a point now. So this statement is correct under correct when thermal deformation restricted completely either in one or two directions. Nowadays, some students are what now? They are referring the chat GPTs now. A model. That is also going to give the incorrect now. Chat, don't try to depend upon the chat GPT. 60% may be correct and 30% may be incorrect now. So you are not in a position to identify which question answer given by ChatGPT is correct and which question answer is given by ChatGPT is incorrect now. Please try to go through the what now standard textbooks. Standard textbooks. Nowadays, I have seen the what some of the students are telling what now. सर मेरे टीचर ने चैट जीपीटी रेफर करने के लिए बोला था सर. चैट जीपीटी what now? 100% not give the correct answer now. Accuracy what now? 100% not there now. 70% correct, 30% incorrect now. So some questions will be the correct, some question incorrect now. So you are in a student level, you cannot identify which question answer is given by ChatGPT is correct and which question answer given by ChatGPT is incorrect now. So always try to depend upon the standard textbooks. Otherwise, learn the concept from a specialist teacher now. Specialist teacher in that subject now. And if you are going to learn the strength of material from a production or thermal teacher, then you are going to likely to make these mistakes now. Thermal teacher, they are specialists in the thermal subjects, they are not specialists in the strength of materials now. And production teacher, they are specialists in the production now. So don't try to answer the questions by using the chat GPT and low standard YouTube videos which are created by a teacher who is not specialist in this subject. This is my suggestion now. So answer for the question is A and B. Answer is A and B. So 2 or 3 friends have given the correct answer now, A, B. Mr. Ashok Kumar is given AB, good. 2 or 3 friends is given Ashutosh Yadav is also given AB, good. Ashok Kumar is also given AB, good. Okay, good. Okay. So once again I am telling now, by chance आपका आंसर गलत हो जाए तो प्लीज डोंट lose your confidence level. Try to identify where you are done the mistake. Try to go through that now. It's a practice only. So try to identify your mistakes now and try to rectify them before going for your final exam. Now, fourth question now. Which of the following statement is or false? First statement true, second question false, third question true, and fourth question false. Only vertical reaction exists at the roller support. Moment reaction is non-zero at the guided roller support. Simply supported beam and overhanging beams are always statically indeterminate beams. Indeterminate beams. And at simple support, bend moment is always zero. At simple support, bend moment is always zero. I hope now at least for this question, I feel I'm going to assume that most of you are going to give the correct answer for this now. Now this is what based upon the different type of supports and corresponding reactions. Only one extra support diya tha, but most of the times we are discussing hinge support, fixed support, roller support. But here it is given guided roller support. Guided roller support. I've already mentioned now. These are all I've framed this question on my experience by referring the previous papers or what I have framed my experience now. These are not from any of the papers. They are not from any of the textbooks. No textbook MSQs are there. So to prepare all this question, I spent sufficient time, almost last 1 week, spend this time for this questions now. Anybody quick? And और एक पॉइंट याद रखो, you are not playing a lottery game. You are playing a game of your future. You are not playing a lottery game. You are playing a game of your future. So don't play with your future. Because some questions here there is no negative, but MCQ there is a negative marking. Negative marking will be there now. तो फिर ऑलरेडी आपने लास्ट 1 ईयर से इतना मेहनत कर रहे हैं, पूरा सब्जेक्ट लड़ लिया था. नाउ यू आर जस्ट गोइंग फॉर द इन द लास्ट स्टेप, गोइंग फॉर योर फाइनल एग्जामिनेशन. तो क्वेश्चन को ठीक से पढ़ लीजिए एंड ट्राई टू यूज योर बेसिक्स एंड ट्राई टू आइडेंटिफाई द करेक्ट आंसर. तो डोंट प्ले विथ योर फ्यूचर. सर ये मेरी GTQ सेशन है सर, इधर मैंने गलत करे तो क्या हो जाएगा सर? सेम थिंग यू आर गोइंग टू द फाइनल एग्जाम ऑल्सो. आवर हैबिट्स आर नॉट गोइंग टू बी चेंज्ड नाउ. हाउ यू आर गोइंग टू बिहेव द टुडे, हाउ you are going to answer today's question, the same thing you are going to do in final exam also. Assume that these are the questions you are attempting in the final GATE examination, GATE 2026 exam now. But if you are not prepared anything, then you can play a game of lottery game play कर सकते हैं. बट एक साल आपने इतना मेहनत किया था, तो आपके ऊपर आप विश्वास रख लीजिए. Try to use your basics and try to answer the questions now. Anirudh C. So if question answer is only Bombay. Only Bombay. Only this statement is true. This statement is गलत है. 1 minute. Is asking false है. 1 minute. False means small correction. So this statement is false है. This statement true है. This statement false है. This statement false है. So only one statement is true. Now is asking false statement, then answers are what now? ACD. ACD. Anybody has given ACD? MacRock is given now. MacRock 4807 ACD is given. Good. MacRock good. Only one friend I found he has given the correct answer now. Good. Most of students are there taking what now? Roller support may need not be a vertical reaction. When you are going to get a vertical reaction at the roller support now, always at the roller support, reaction will be what now? Perpendicular to the plane supporting the rollers. Roller support में always reaction will be perpendicular to the plane supporting the rollers. So when you are going to get a vertical reaction, if the plane supporting the rollers is a horizontal line, now this is about a plane supporting the rollers, then you are going to get a vertical reaction. If the plane supporting the rollers is about now inclined, then you are getting about now perpendicular, but that will become as what now? वन वर्टिकल एंड वन हॉरिजॉन्टल रिएक्शन मिलेगा। ऑलवेज एट रोलर सपोर्ट एक ही रिएक्शन मिलेगा एंड दैट रिएक्शन इज व्हाट ना परपेंडिकुलर द प्लेन सपोर्टिंग द रोलर्स। If the plane supporting the rollers is parallel to axis of the beam, if the plane supporting the rollers is parallel to axis of the beam, then this statement is correct now. The plane supporting the rollers is parallel to longitudinal axis of the beam, then this statement is correct. But he has not mentioned anything now. So when this statement is correct now, if the plane supporting the rollers is a horizontal line or parallel to longitudinal axis of the beam, guided roller support will permit the rotation, but guided roller support will restrict the rotation. ये दोनों में फर्क क्या है? This will permit the rotation, therefore your moment reaction is zero, but this will restrict the rotation, then moment reaction non-zero है. And everybody is taken to that true now. Simply support beam, overhanging beams are not always statically determined. Always बोला था, they are statically determined, but except which case now? When they are supported by two hinge supports in presence of axial load. A simply support beam supported by two hinge support and subjected to inclined load. Then आपको चार रिएक्शन मिलेगा। चार रिएक्शंस तीन स्टैटिक इक्विलिब्रियम इक्वेशन से नहीं निकाल सकते हैं। But most of the textbook they are mentioning what now? Simply supported beam and overhanging beams are statically determined. They are statically determined except in which case now? When they are supported by two hinge supports and subjected to axial load. Suppose if there is an inclined load is there. Then you are getting what now? One but RAB, RBB, RAH, RBH. now चार अननोन थे, चार रिएक्शन थे, चार नॉन जीरो रिएक्शन थे, इक्वेशन तीन ही है, so the statically indeterminate है. Now here you need a compatibility equation. So when this statement is correct now, when they are except only in one condition, which condition now? There are always what a statically determined except only one condition, which condition now? When they are supported by two hinge supports and subjected to axial load. So this is statically indeterminate. So it always mentioned किया था, that's why this statement is false है. And simple support bendment is zero. It is not correct now. Simple support में हमेशा moment reaction zero है. Simple support में moment reaction zero है. Simple support means generally roller support and hinge support. दोनों rotation को permit करेगा, moment reaction zero है. But bendment need not be zero. Bendment may or may not be zero. At simple support में bendment may or may not be zero. May or may not be zero. So this is overhanging beam. So here bendment is not zero, but the bendment now minus m. But here bendment is zero, but here bendment is not zero, minus m है. So simple support में हमेशा moment reaction zero है, but bendment may or may not be zero. Here bendment is zero, but here bendment is how much? No, minus m है. So that's why, but most of the techniques they are mentioning what now? Simple support bend moment is 0. Default simple support means roller and hinge supports. So answer for the question is what now? ACD. False statement. True बोले तो answer is what now? Bombay. So this is the answer for the question now. Once Anuruddha given the correct answer now. That's why what now? MSQ is important. Each and every word को क्वेश्चन को स्टेटमेंट के ठीक से पढ़ना है. ऑलवेज बोला था, ये ऑलवेज नहीं तो ये स्टेटमेंट ट्रू है. हियर आल्सो ऑलवेज मेंशन किया था. दैट इज द स्पेशलिटी ऑफ एमएसक्यू. दैट इज द स्पेशलिटी ऑफ एमएसक्यू. So answer is what now? ACD. Now we'll come for the next question now. Okay. Which of the following statement is or true for a point under biaxial state of stress such that sigma x is 0, sigma y non-zero, tau xy non-zero. A point is under biaxial state of stress. Sigma x 0 है, sigma y non-zero है, tau xy non-zero है. Now is asking which statements are true पूछ रहे. Which statements सही है पूछ रहे. Try to read the question properly, and wherever required, try to draw the diagrams now. So this is the state of stress given. Now is asking for this one, which statements are true. For the first statement now, planes of pure shear stress exist and they are non-complementary planes. Planes of pure shear stress exist हो जाएगा and they are non-complementary plane. Planes of pure shear stress may or may not exist. Means out of these two statements, one should be correct and obviously other one should be incorrect now. And shear stress and planes of zero normal stress equal to absolute maximum shear stress. And Mohr's circle is unsymmetric about origin and its center may lie either on positive y-axis or negative y-axis. Positive or negative y-axis. X-axis, sorry. Positive or negative x-axis. What's long time, my dear friend? Somebody पूछ रहा है long time बोल रहे हैं. इसका मीनिंग क्या है? So for this question, answer is what now? A and D. So this is true. This is false. This is false. This is true. The answer for the question is A and D. A and D. Obviously, this plane is about now plane of. This is what now? प्लेन ऑफ प्योर shear stress है, एक ही shear stress है, but this is not plane of pure shear, means they are not complementary. So plane of pure shear exist करेगा, but they are not complementary plane. When the plane of pure shear stress are complementary under pure shear state of stress, planes of pure shear stress will become as a complementary under pure shear state of stress. That is when sigma x plus sigma y 0. And when shear stress on planes of pure shear stress equal to absolute tau max, this is statement is when true now. This statement is true when sigma x plus sigma y is 0. And obviously here what now? Principal stress are unequal and unlike in nature. In this case, principal stress are unequal. When the principals are equal and like in nature and a pure shear state of stress, here principal stress are what now? Sigma 1, sigma 2 are unequal and unlike. अनइक्वल है, अनलाइक है, तो इसीलिए क्या हो जाएगा? मोर सर्किल इज अनसिमेट्रिक अबाउट द ऑरिजिन. इफ द सिग्मा 1 इज पॉजिटिव, then center will lie on positive x-axis. If sigma 1 is negative, center will lie on negative x-axis. So in this case sigma y positive है, then sigma 1 is also positive. In this case Mohr circle center lies on positive x-axis पे रहेगा. Suppose sigma y negative हो जाए तो Mohr circle center will lie on negative x-axis पे रहेगा. So answer for the question is A and D. A and D. So most of the students have given the correct answer for this now. Good. For this question, majority has given the correct answer A and D. Good. Okay. So now we come to these are the some MSQ questions I taken now. Now, can you give the answer for this now? This is NEAT question now. The ratio of elongation of the upper half to the lower half of a conical bar due to self weight. What is the ratio of elongation of the upper half to lower half of a conical bar due to self weight? So I'll give 2 minutes time. So try to give the answer now. Anybody vote the? Now this is a conical bar now. I was asking what is the weight of this one is W, that is gamma AL by 3. What is the ratio of the upper half? That is what the pink color one. This I am calling 1. And bottom half, upper half to bottom half due to self weight. What you have to do, how to get the elongation? Take a small strip, find out the change in length of the small strip, then do the integration. First find out the change in length of the small strip, then identify the limits, then do the integration, then you'll get it now. If the x is measured from bottom, so for this one limits are what? 0 to L by 2. For this one limits are L by 2 to L. मैंने x नीचे से मेजर कर रहे, तो इस केस के लिए लिमिट्स आर व्हाट ना 0 to L by 2. इस केस के लिमिट्स आर L by 2 to L. Anybody what the answer now? Good. If it is given 4 by 3, 1:3, that is what? A 3. 3 the answer now. Good. So this answer is 3. Some students have given 1:3, 3:1. Change in length of the small strip. Axial load at x6. Length of the small strip. Px6. What the axial load at x6 now? Gamma I'm measuring the x from bottom now. Everywhere Young's modulus is same. So this will be what now? Gamma I'm measuring the x from the bottom. To the arbitrary section. X. So for this one limits are what? 0 to L by 2. This is what now? L by 2 to L. Now so upper half के लिए lower half के लिए which is same now? Gamma same है, E same है. So simply you have to take the ratio of what? X now, integration now. Upper half के लिए lower half के material same है, gamma same है, E same है. L by 2 to L. Lower of 0 to L by 2. So simply what now? L by 2 to L. X integration, only limits will change now. Complete this integration, you are going to get the 3. The answer is 3. And even if the same question given what? A prismatic bar, answer is same. I done with a conical bar. In place of conical bar, even if it is given prismatic bar, answer is same now. So this 3 is valid for what now? For both conical bar and prismatic bar. Conical bar and prismatic bar, दोनों के लिए आंसर सेम है. So answer is 3 for this question now. You do it anything, the answer should remain same. Elongation पूछे तो obviously you have to assume it is a vertical conical bar. If it is a horizontal conical bar, then it will become as a what now? TSL लगेगा. elongation पूछे तो obviously that you have to assume that about ना vertical conical bar पूछ लेना है. Only what ना self weight of a vertical bar will become as the axial load now. Self weight of a horizontal member will become as a TSL. So whenever elongation पूछे तो that member को vertical लेना पड़ेगा. Answer is 3. Okay. So can you give this question now? Quick. So previous question is everybody is given correct answer. Now, an isotropic body. It is also simple question. So some question are taken simple. Some they are going to mix the questions. Now some are straightforward. Some are concept required. Some are calculation required. They are going to mix the questions. Now some are simple questions are there. Some are concept oriented. Some are what now? Formula based. Numerical calculations are going to be required now. Okay. An isotropic body subjected to state of stress given by sigma x is 10, tau xy minus 20, assuming G is equal to 0.4 E, then dilatation is. So previous question, everybody is given the correct now. Good. Dilatation. First of all, you should know the meaning of dilatation. Anybody give the answer? No, quick. We'll wait for some time. A. Good. Who is given? Ashutosh Bansal is given A. Gangadhar A. Good. So the answer is they have given the correct answer now. A. It's a simple question. Why are given this now? You should know the first dilatation. Dilatation means volumetric strain. Volumetric strain. How to find out the volumetric strain? Volumetric strain is dilatation means volumetric strain. Or you can use the epsilon x plus epsilon y plus epsilon z. Some students are going for the equation and they will calculate the principal stress. Sir, shear stress B has, sir. There is no effect of shear stress. Use any equation, you get the same now. So directly you can use the first one. So some students are going to use the equation. Getting the answer is not a criterion. Getting the answer is not a criterion. You should get the correct answer within a less time. Even you are able to skip one calculation, then you are able to save 1 minute time now. So the time is very, very important. Try to behave like a flywheel. Try to behave like a flywheel. Time is important. Accuracy is important. Speed is important. Wherever required, try to use the shortcut methods now. Most of them are using this now. They will find out the principal stress, then they will substitute it now. But those who are use this one, that is a simple, directly what now? ओनली सिग्मा एक्स इज गिवन ना, तो क्या चाहिए आपको, पॉइजन रेशियो चाहिए. नाउ दैट गिवन व्हाट नाउ, G is equal to 0.4 E. G is equal to 0.4 E. Now first E is equal to then go for the mu. For the mu value you are getting now 0.25. Then go for this now, volumetric strain. One minus sigma x is 10, sigma y 0, sigma z 0. So simplify, you will get it. So first of all, you should know what is the dilatation. Should be thorough with the different terminology. And some students are using this now. Then they will calculate the principal stress. The simple question, most of them are going to give the correct answer now. But if you use this one, you need a one more extra step is required now. It's a waste of time now. सर मैंने इक्वेशन, कोई भी इक्वेशन यूज कर दीजिए, आपको आंसर शुड बी द सेम नाउ. फॉर एवरी क्वेश्चन आंसर इज सेम. यू कैन यूज एनी मेथड, आंसर शुड बी द सेम. So try to get the correct answer within a less time. So answer for the question is going to be A. Good. Good. Option A. Amitesh Kumar. Okay, good. Next, we'll come for the most of them have given the correct answer now. Now, this is from thermal stress now. Question number 8. Maximum shear stress in the rectangular block. There is a rectangular block. You have to find out the maximum shear stress in this rectangular block and change in thickness of the rectangular block. Change in thickness. This is thickness now. As shown in figure, due to a temperature rise of 100 degrees centigrade. So temperature increased by 100 degrees centigrade. तो इस केस के लिए अपने मैक्सिमम शियर स्ट्रेस फाइंड आउट करना है और चेंज इन थिकनेस भी फाइंड आउट करना है. दिस इज लेंथ, दिस इज व्हाट नाउ विड्थ एंड दिस इज थिकनेस नाउ. कोएफिशिएंट ऑफ थर्मल एक्सपेंशन दिया था, अल्फा वैल्यू दिया था, यंग्स मॉडुलस दिया था, जी दिया था. तो कैन यू गिव द आंसर नाउ क्विक. It is restricted in two directions. It is restricted left and right and top and bottom. दोनों डायरेक्शन पे restrict किया था. Most of the gate paper अभी तक they are asking either restricted in one direction or restricted in three direction पे पूछ रहे हैं. अभी तक इस टाइप ऑफ क्वेश्चन नहीं पूछा था. This type of questions are available in the Karnataka textbooks till 2025. Gate 2025. They are given the questions. They are given the questions either restricted in one direction or restricted in three direction, but it is restricted in two directions. Length, width and thickness. इस केस के लिए मैक्सिमम शियर स्ट्रेस फाइंड आउट करना है और चेंज इन थिकनेस भी फाइंड आउट करना है. Anybody quick? This is T. Length is 1 meter. Width is what now? 400 mm. थिकनेस दिया था, थिकनेस 50 दिया था बंसल। मैक्रॉक 200 दिया था shear stress। थिकनेस इज 50। अपने चेंज इन थिकनेस फाइंड आउट करना है। चेंज इन थिकनेस फाइंड आउट करना है। So answer for the given question is, for this question answers are answer is 133 point and change in thickness is so two friends has given what? McRock and other friend is given 200. No, 200 is not correct. No, 133.33. First, you have to find out the Poisson's ratio. So this is a generalized equation for thermal stress. This is a generalized equation for thermal stress. This equation I have already given in the classes. Those you are remembered, then directly can give it now. Otherwise, you have to go for the basics now. For the basics now, you can equate the total strain in x direction. Those you are remembered the equation directly लिख सकते हैं. Answer you can give it directly. But those you are unable to recollect this now, then अपने basic से करना है. If I am assuming the x direction, total strain in x direction को equate to 0, then you will get the stress now. Either equate the strain in x or y direction, total strain. So directly what now? What is the beta value now? Beta is equal to 1 for what now? Restricted in one direction. Beta is equal to 1 for restricted in one direction. This equation I have already given in what now? My SOM QRC. Those who have attended my classes, this is already given, and otherwise who have not attended my classes now, I have given the SOM QRC, quick revision course of my strength of material. 15 hours I have taken now, where I have already given this now. Beta is equal to 1 for completely restricted in one direction. Beta is equal to 1 minus mu, restricted in two directions. beta is equal to 1 minus 2 mu, restricted in 3 directions. So beta is equal to either 1 minus mu so this is advantage now. Now this is what now restricted in 1 direction, restricted in 2, this is restricted in 3. So they restricted in 2 directions, therefore you put it 1 minus mu. So first find out the Poisson's ratio. First find out the Poisson's ratio, then you can substitute it now. Thermal stress is alpha. Alpha is change in temperature is 100. And Young's modulus is beta. Beta is what? The 1 minus mu. For the mu value in a 0.25. The mu is what? For this case, the mu is so the 0.75. So now thermal stresses, we are getting thermal stress value is 266 point. Compressive. $266.67 compressive because temperature increase in the compressive. Now it's asking maximum shear stress. Here you are going to get a biaxial state of stress. What is the state of stress you are getting here now? Biaxial state of stress. Biaxial state of stress. So some students are going for 0 now. In plane Tomax 0 है, absolute Tomax 0 नहीं है. Member पे पूछ रहे, member पे बोला तो absolute Tomax. Your sigma 1 and sigma 2 like in nature है. So what is the maximum shear stress now? Sigma 1 by 2. So it is 133.33 megapascals. 133.33. Good. Bansal has given the answer now. Okay. Next is asking change in thickness. How to find out the change in thickness now? Epsilon z is equal to 1 by E sigma z minus of plus thermal strain alpha delta T. So here sigma z 0, but the sigma x and sigma y minus of 2 times the thermal stress. Now change in thickness upon thickness. Thickness is 50. Young's modulus is 200. Zero. Mu is 0.25. Sigma x plus sigma y is what now? Both are equal and like in nature. Minus 2 times the thermal stress. So this will be what now? Then alpha delta T. change in temperature is 100. Then complete this calculation, you will get the delta T. So this is the answer for this question now. Okay, good. Prakash Pathak is given the correct answer. Good. I hope Prakash Pathak is from online batch now. He has attended, Prakash Pathak is attended online. Good. So same thing, restricted in 3 direction. This is what now? A small correction. This is made a mistake. Small. This is 1 minus 2 means. Small correction is required. मैंने गलत किया था इधर. This is मैंने बोला था but इधर गलत लिखा था. 2 minus mu लिखा था. ये 1 minus 2 mu है. Restricted in 1 direction 1. Restricted in 2 direction 1 minus mu. Restricted in 3 direction 1 minus 2 mu है. But these are all valid when the expression is valid. Now prismatic member made of same material whose thermal deformation restricted either in 1 or 2 or 3 completely. Partially restrict के लिए valid नहीं होता है. But सर मुझे equation याद नहीं है तो क्या करना? Use the basics. Go for the epsilon y is 0 or epsilon x equal to 0. Write down the epsilon x 1 by e sigma x minus mu sigma y plus sigma z plus thermal strain equal to 0. That we can do it now. So this is the answer for the question now. Most of them have given the correct now. Good. So still those who are not attended gone through my QRC. Almost I taken 150 hours during my offline and online classes, strength of material. If you want to quickly revise your total strength of material, आप revise करना है तो my suggestion is what? Try to go through my strength of material QRC. I have given in 15 hours now. All the shortcut methods, all the conclusions, and all the equations. That is the best way to revise your strength of material before going for the examination. अपने पूरा my notes पढ़ना है तो it will take more time now. So that 150 hours I have given in what? 10% of the time now. 15 hours I have given now. Still some students day before yesterday, online batches now. Sir, I am not familiar with QRC, quick revision course. Like this, what the MEDIZ teachers are conducted all their subjects QRC, 10% of time. So 50-hour subject, 5 hours, they are given the total. Quick revision is given there. That is the best way to revise your total subject now. That is my suggestion. So many students, so many of the toppers, not only MEDIZ and some of the non-MEDIZ students also gone through the what now? My SOM QRC. And this year I slightly modified also. Okay. So can you give the answer now? For the bar as shown in figure, maximum shear stress in the bar is dash megapascals. A bar is fixed at both the ends now. Assume the bar is now non-uniformly heated. There is a small printing mistake. This is non-uniformly heated. Small typographical mistake, non-uniformly heated, such that change in temperature at an arbitrary cross-section located at a distance of x meter from left hand side support. He has given the change in temperature is given at a distance of x meter from left hand side support. 100 x square upon L square degree centigrade, where L is the length of the bar. What the length of the bar? No, 5 meters. Now, इस केस के लिए क्या पूछ रहे हैं आपको? मैक्सिमम शियर स्ट्रेस पूछ रहे, the combined. This is question is given one of the very oldest gate paper in 1990s दिया था. 1990 gate is given in what on started in around 98 or 88. This question is given one of the very old PYQ gate mechanical PYQ 1990. So your thermal stress and torsion both are combined now. So here change in temperature is given now. But the change in temperature is given 100 x square upon L square. When change in temperature varying parabolically. So your change in temperature is 0 and your change in temperature 100. Your x value kitna L hai. Total length is L hai. L means 5 meters hai. So your change in temperature 0 hai. Your change in temperature 100 hai. So change in temperature varying from 0 to 100 parabolically. Change in temperature varying from 0 to 100 parabolically. And there is a twisting couple is given now. I is asking what is the maximum shear stress in the bar. कितना स्ट्रेसेस मिलेगा ड्यू टू चेंज इन टेम्परेचर से आपको थर्मल स्ट्रेस मिलेगा. द थर्मल स्ट्रेस विल बिकम एज एक्सियल स्ट्रेस ना कंप्रेसिव एंड ड्यू टू ट्विस्टिंग कपल से आपको टॉर्शनल shear stress मिलेगा. Then you are getting a combined state of stress. So on the cross section you are getting what now? One normal stress due to change in temperature, normal compressive stress, and one torsional shear stress. So cross section you are getting combined stress now. Then principal stress concept is required now. So first what you have to do it now? सुपरपोजिशन यूज कर दीजिए, सुपरपोजिशन प्रिंसिपल यूज कर दीजिए. पहले इसको नेग्लेक्ट कर दीजिए. फर्स्ट नेग्लेक्ट दिस ट्विस्टिंग कपल, देन दिस विल बिकम एज व्हाट नाउ? कंप्लीटली रिस्ट्रिक्टेड डिफॉर्मेशन. पहले नेग्लेक्ट कर दीजिए ट्विस्टिंग कपल को, देन यूज द व्हाट नाउ? कंप्लीटली रिस्ट्रिक्टेड नाउ. So this is what now? Thermal stress into area. Now to find out the thermal stress here now. Thermal stress is what now? It is a non-uniformly heated. So this is valid what now? Uniformly heating. This is valid what now? Uniformly heating. Means change in temperature everywhere is same. But this question is what now? Here I have assumed the change in temperature is uniform. अरे क्रॉस सेक्शन पे चेंज इन टेम्परेचर सेम लिया था. But here change in temperature is what? A varying 0 to 100 parabolically, non-uniformly heated है. What the thermal stress now here now? Restricted in one direction, then beta is equal to 1. Then C is what now? C is equal to 1 for uniformly heating है. Non-uniformly heating है तो this value is what now? 1, 2, 3, 4. C. So C is equal to what now? It's also given now. Uniform change in temperature, linear change in temperature, parabolic change in temperature. T is equal to 1, UTV. UTV means what? Uniform change in temperature. LTV, linear change in temperature. Parabolic change in temperature. And cubic parabolic. Here is what now? So what the C value? Change in temperature function of x square. So C value is what? A 3. In this case, C value is 3. Now you can calculate this value now. Then this thermal stress you are getting 66.67 minus means compressive. Minus means compressive. Then due to twisting couple से क्या मिलेगा? Torsional shear stress मिलेगा. Next, neglect the change in temperature. Next, assume only twisting couple acting. पहले ये twisting couple को 0 कर दीजिए. Then बाद में change in temperature को 0 कर दीजिए. Then assume only twisting couple is acting at the, the statically indeterminate. Then how you are going to get the reactions now? Statically indeterminate. Then how to find out the reaction? By using a compatibility equation. Theta 1 plus theta 2 0. But you can use the 1 second shortcut method now. Either clockwise. Then the reactions are PA, PC. Two reactions are there now, statically indeterminate. Then you have to go for the angle of twist of AB plus angle of BC should be equal to 0. Instead of this one, you can use the shortcut method now. When GJ is same, but the TA now, these both are in opposite direction hai. Then this should be taken a plus, multiply by distance with the other support now, T into 4 upon distance between the supports. So TA is equal to T multiplied by 4 by 5. So this is 0.80. But when this method is valid now, when GJ is same, torsional rigidity is same. Otherwise, you can go for a general method, theta 1 plus theta 2 equal to 0. So this will be 400 Newton meters. Obviously, what the TC now? How to get the TC? How to get the TA now? Both are opposite direction hai. Isko positive lena hai. Then multiply by distance with the other support 4 upon the distance between the supports. Once you know get the TA is 400. What about the TC now? 100. So what the maximum torque now? Torque in AB, that is TA. Then tau xy equal to tau T max 16 T max upon pi d cube. So complete this calculation of this value you are getting 130.379. Then what the state of stress here now? This is the state of stress. So whenever normal in one direction is 0, principal stresses are unlike in nature. When the principal stresses are unlike in nature, in plane tau max and absolute tau max both are same. Since normal in one direction is 0. This is what now? thermal stress. This is sigma x. This is tau xy. So when normal stress in one direction is 0, when normal stress in one direction is 0, principal stress are unlike in nature. Means in plane Tomax and absolute Tomax are same. That is equal to radius of the Mohr circle. So directly for the absolute Tomax, radius of the Mohr circle 1 by 2 square root of sigma x minus sigma y whole square plus 4 tau xy square. Here principal stress are unlike in nature. Some students will calculate the principal stress, not required now. Sir, while both are same, no, principal stress are unlike in nature. Sir, how do you know principal stress are unlike in nature? कभी भी नॉर्मल स्ट्रेस एक डायरेक्शन पे 0 हो जाए तो, कभी भी नॉर्मल स्ट्रेस एक डायरेक्शन पे 0 हो जाए तो प्रिंसिपल स्ट्रेस आर अनलाइक इन नेचर. Then in plane Tomax and absolute Tomax are same. So what this value now? 1 by 2 sigma y 0. I can substitute it now. So already got the thermal stress मिला था 66.67 and tau xy मिला था. Tau xy is how much now? 130.37. So substitute these values now, and this value you are getting 134.573. So the answer for the question is 134.573. This is the answer for the question now. So here this question is what now? We have combined the concept of 3 chapters now. Thermal stress, torsion and principal stress chapter now. This question is a combination of what now? 3 chapters now. Thermal stress topic, torsion chapter and principal stress chapter. So completely strength of material is what now? Application of the concepts gained from the different chapters now. So those who are thorough with these 3 chapters, they can do this question now. So one friends are given the correct now. Kadir Ansar is given 134. Good. Macrock is also given 134.573. Good. Otherwise, what now? If you go for what now? Systematically take the more time now. UTV means uniform change in temperature. LTV means linear change in temperature. PTV means parabolic change in temperature. Cubic parabolic. But these are all valid when change in temperature vary from 0 to maximum. All these constants are valid when change in temperature is varying from 0 to maximum. It is varying from what now? Minimum to maximum valid nahi hai. These are all valid what now? When change in temperature varying from 0 to maximum hai. Here change in temperature 0 hai because x is 0 hai, and here change in temperature maximum hai. So change in temperature varying from 0 to 100. 0 to 100 parabolically. Then C is equal to what now? 3. C is equal to 3. So this is the answer for question number 9. Okay. Now we will come to the SFD BMD now. This is one of the very old gate mechanical paper question. I slightly modified it now. This question was there. Old Made mechanical workbooks was there now. For the structure as shown in figure. Axial load, shear force, bendiment, twistment at the fixed end. At the fixed end is asking what now? What is the axial load, shear force, bendiment and twistment? The structure. and here load is applied dot. What is the meaning of dot now? Perpendicular to the plane of the board. At this end, a load is applied in the perpendicular to the plane of the board. Dot. But in the gate paper is given, cross is given, means inward is given now. And what the P value is given now, 10 kilonewton. Capital L is given 4 meters. Capital L is given 4 meters. Quick. So once again, concept oriented now. I'm calling this as A. This is B. C. And this is D. Load is applied at D, perpendicular plane of the board. So for CD member is a horizontal transfer shear load. For this BC member, horizontal eccentric transfer shear load. And AB member is also once again what now? Horizontal eccentric transfer shear load. This is what now? Inclined line, perpendicular plane of the board. I was asking at A. So for this member, this will become as a horizontal eccentric transfer shear load. What should be the first step now? Introduce the two dummy forces at E. Introduce the two dummy forces. Whenever a eccentric load, what the concept now? Two dummy loads should be introduced in such a way that they are parallel, equal. They should be what now? Equal and opposite, and they should be parallel to P. So this is the outward. Therefore, introduce here. This P1 equal to P, P2 equal to P. What about P and P2? No, they will form a twisting couple. P is outward, this P is outward and P2 is inward. The bottom P is what now? Outward, and the top P2 is what now? Inward. So these two will form a twisting couple in the clockwise direction, and this will become the horizontal transfer shear load. Now draw the free body diagram for AE. What this length? No, 3L by 4. This is also 3L by 4. This is L by 4. So now you can draw the free body diagram for and this P and P2. This P and P2 will form a twisting couple in clockwise direction, seeing from the right side. So this will what now? Double arrowhead. What the eccentricity value now? L by 2. L by 2. This distance how much now? L by 4. L by 4. Now you can enter the reactions at A. One twisting couple reaction, TA is equal to PL by 2, and this P is outward, then here it should be inward, should be there now. Here reaction should be inward. The inward. Inward. Next, P into L by 4. It will give a what now? Couple in which direction? A moment in what now? Horizontal plane clockwise. Then reaction is what now? Anti-clockwise. P into L by 4. It will give a moment in clockwise direction in horizontal plane. Then reaction is going to be horizontal plane anti-clockwise. So here एक moment reaction P into L by 4, but this is in horizontal plane. So total how many loads will be at the fixed end? No, there is no axial load. Axial load is 0. Shear force P. This P and this P is forming a couple in horizontal plane clockwise. So shear force positive P, and there is a bending couple is there now. And this is in horizontal plane coming on the front side. So bendment is what? Now minus PL by 4. And twistment is what? Now PL by 2. So at A, axial load is 0. Shear force is plus P. But P value is how much is given in the question now? Plus 10. And bending moment is what now? It is what? A horizontal plane coming on the front side, front contraction negative. So bending moment is what now? Minus PL by 4. So it will be what now? L value is how much now? 4. Therefore this is minus 10. And twistment is positive. So it is plus 20. So these are the answer for the question now. So these are the answer for the question now. Already given. Love Keshav Mishra, AL0 shear force PL by 2. And Ashutosh Bansal is given now. Correct now. Prakash Pathak. Okay, good. but most of the students they are going to give the plus 10, this is a minus 10 hai. Front contraction is negative hai. So answer for the question is 0 plus 10 minus 10 kilonewton meter and plus 20. This I done in the class, but GATE exam ने क्या पूछा था? AB and CD of same length दिया था. GATE exam पे AB and CD को दोनों same length दिया था. If AB and CD are same, what happens now? AB and CD are same length, then answers are what? Abandonment is 0. This I done in the class, but in the exam is asked what now? If AB and CD are same length, then what is the answers now? Axial load is 0. Shear force is what? The same, plus 10. Bend moment is 0. Bending moment is 0. And twisting moment is plus 20. But in GATE examination, numerical nahi diya tha. It asks only which loads are going to exist now. Then which loads will exist now? Shear force and twisting moment will exist now. Axial load and bend moment is 0. Axial load and bend moment is 0 if AB and CD of the same length now. So whenever a eccentric load, what the principle now? Two dummy force should be introduced such that they should be parallel to applied load and they should be equal and opposite. This is outward. Therefore, here two dummy force introduced such that they are equal and opposite and they should be parallel to this now. So this P and P2 will form a twisting couple. Clockwise direction from right side, it is towards left side now. So this is the answer now. So most of the friends also given the correct answer. Good. Kadir Ansari, Priyansh Raj. Good. Okay. We'll come for the next question now. Now, can you give the answer for this now? For the cantilever beam as shown in figure, support reactions are. This is a similar question you are discussed in the class. Because in workbook, I included each and every question now. In every chapter, you have discussed almost 50 questions now. So those you have gone through my class notes, workbook and PYQ. For them, they can do all these questions now. But in the class, we are done with about a simply supported beam with a distributed, but there is a cantilever beam. For the cantilever beam as shown in figure, support reactions are. Load intensity at the free end is W. And load intensity at the arbitrary section W cos pi x by 2L. This is W cos pi x upon 2L. सर x किधर से मेजर किया था? No, you can check it now. इधर load intensity W दिया था. When this load intensity will become as a W now, and this should become 0 now. So this term should become as a 1 now. When this term will become as a 1 now, when x is 0 now, cos 0 is what? A 1. Therefore, x is measured from which side now? Left side now. Here load intensity कितना दिया था? W दिया था. Then when this value will become as a W now, when cos pi x by 2L is 1 now, means x should become 0. Cos 0 is 1 now. So x is measured from the free end. That's all. Now is asking support reaction. Fixed support में कितना reaction मिलेगा? 3 reaction. एक vertical reaction, एक moment reaction and एक horizontal reaction. But there is no horizontal reaction. एक vertical reaction मिलेगा, एक moment reaction मिलेगा. Horizontal reaction will become zero because there is no axial load. Now how to find out the vertical reaction now? So this vertical reaction will become the shear force. At a support, the vertical reaction nothing but the shear force. And moment reaction will become as a bending moment now. So you have to find out the bend moment and shear force now. Here you have to find out the shear force. That shear force magnitude is equal to vertical reaction. And the bend moment at the fixed end is equal to moment reaction. Then you can go for the basics now. So can you solve this now? So directly I'm giving, complete this now. So substitute the W value, then do the integration. Then we'll get the C1. How to find out the C1 now? By using the boundary condition where the shear force 0 now. At A, shear force and bend moment both are 0. At this end both now, free end both shear force and bend moment are 0. At the fixed end both are non-zero now. At free end both are 0. So when x is equal to 0, shear force 0. Then you can find out the C1 value now. So minus so from this one, fxx is equal to minus now you can find out the C1 now. How to find out the C1 now? By using the boundary condition. At free end shear force 0, that x is equal to 0. X is equal to 0. Then from this one, C1 value is how much it now? 0. Sin 0 is what? A 0. So C1 is 0. So what the shear force equation now? Minus 2WL upon pi. Now from this one, you can find out the maximum shear force. Where the is asking about a vertical reaction now. That vertical reaction equal to shear force. So this is the maximum shear force. X is equal to 0. Or x is equal to L. Now x is equal to L. So this value is what now? Sin pi by 2. Sin pi by 2 is what? A 1. So this value will be what now? So shear force is negative. Here shear force negative means what now? Vertical reaction should be upward. So directly this itself what now? Vertical reaction at B. WL upon pi. 2WL upon pi. Means either A or D should be correct now. Either A or D should be correct now. Then how to identify the bendiment now? A or D should be correct now. Now I can use the elimination process now. Now this is giving a moment in which direction? Now clockwise. This is giving a moment in clockwise. Then moment reaction is anti-clockwise. So this is also given anti-clockwise. This is also given anti-clockwise. Then we cannot directly decide. You should also find out the bendiment now. Then you can use the then fx equal to dm by dx. One more time, do the integration. Then find out the C2. How to find out the C2? Now by using the boundary condition of bendiment. Where the bendiment is 0 now at A, x is equal to 0, bendiment is 0. Then you can find out the C2 value. Same procedure you can do it now. So once again, substitute this shear force equation, first time integration, then find out the constant by using the boundary condition of bendiment, that x is equal to 0, bendiment is 0. Then once you get the bendiment equation now, how to find out the bendiment at B? X is equal to L. So this is completed. So directly I am giving the answer for this now. Bendiment at B. X is equal to L. So this value you are getting minus 4L square by so not directly given the procedure, complete the numerical calculation now. You are getting a negative. The bendiment is negative means what now? Hogging. Hogging means it is going to be clockwise direction now. So what should be the moment reaction now? Moment reaction will be so answer is what now? Delhi. Answer is Delhi. Answer for the given question is Delhi. So most of the friends have given Kumar Anant. Kumar Anant is Delhi. Ashutosh Bansal is Delhi. Somebody is given Timmy, LISSP. I don't know what is the short form. Don't use the short forms. I already explained now. Substitute the shear force equation here now. Do the integration now. Then you are going to get a bendiment equation. Then you are getting a constant. How to find out the constant of integration? By using the boundary condition. Once again, at x is equal to 0, bendiment is 0. Find out the C2 value. Then write down the bendiment equation. In that one, substitute the x is equal to L. Then you are going to get this value now. But bendiment I am getting negative means hogging. Hogging means right hand side negative. Negative means it should be a clockwise. Anti-clockwise a positive. Anti-clockwise a positive on the right hand side. Clockwise a negative. The moment reaction is what now? 4L square by pi square into W. Answer is Delhi now. Okay. So if a student can give the answer for this question, if a student can give the answer for this question correctly, is completely thorough with the what now? SFD, BMD as well as the bending stress chapter now. Similarly, what this question is given in a similar question is given, but I modified it in the GATE exam, probably GATE 2022 or 23. They asked what now? PMD is asked now. For the cantilever beam as shown in figure, which of the following statement is are true? The completely concept oriented question. Completely, this slightly what now? A cantilever beam loaded with a UDL with an intensity of 8 kilonewton per meter and a constant point load, horizontal constant point load inward. जनरली क्लासेस में क्या डिस्कस करेंगे? एक ही यूडीएल है, बट हियर ए कांस्टेंट पॉइंट लोड इनवर्ड है, हॉरिजॉन्टल concentrated point load inward है 3 kilonewtons. Now this is a cross section. Cross section at the fixed end means the left side view. This can be seen from the left side and drawn on the right side. This is a cross section. Now what is asked the question now? Maximum bending moment is 5 kilonewton meter. Critical points on the cross section at fixed end are DEF. These are the critical points are given now. And bending stress at JC, this F is not there, JCK. JCK is 0. At this 3 points, bending stress is given as 0. And maximum bending stress 15 megapascals. Maximum bending stress is 15 megapascals. Can you give the answer now quick? Use the superposition now. First assume only UDL. Then you are going to get a vertical bending. Hogging bending, you are going to get it. And due to this one, you are getting a horizontal bending, backside contraction, positive. Due to UDL, hogging, bottom contraction. So BMD is about a negative. And due to this load, what now? This load is going inward. It will give a moment in which direction? Anti-clockwise. Then moment reaction is clockwise. The backside contraction is positive. So due to this P, you are going to get a positive triangle. And due to UDL, you are going to get a negative parabola. So where the bendment is maximum at A. But the bendment at A, two bendments मिलेगा. एक UDL से bendment in vertical plane, and due to this P, we are getting a horizontal. So what the bendment at A means? Resultant bendment. What the resultant of H and V? Square root of H square plus V square. तो फिक्स्ड एंड पे यूडीएल से एक बेंडमेंट इन वर्टिकल प्लेन में मिलेगा एंड ड्यू टू पी से एक हॉरिजॉन्टल बेंडमेंट मिलेगा. व्हाट द रिजल्टेंट बेंडमेंट? स्क्वायर रूट ऑफ एमएएच होल स्क्वायर प्लस एमएवी होल स्क्वायर, एमएवी होल स्क्वायर. This is what now? Hogging, negative. This is what now? VBMD, vertical bending moment diagram. What this value now? WL square by 2. WL square by 2. So this value we are getting now is a vertical bending. Is a vertical bending. Here which is the neutral axis? This is a neutral axis. Therefore here bending stress is 0. Here bending stress is 0. This will become the neutral axis. Neutral axis. At all these points, bending stress is 0. And here bending stress is maximum. And they are hogging. So bending stress is what? A positive. Here bending stress is positive. Here now to find out the sigma B max now. Max upon section modulus. M max malum hai. Now you can find out the sigma B max. M max upon section modulus about neutral axis. Which is the neutral axis now? HCA. Now you can substitute it now. So what the bending moment value now? This is 4 into 10 power 6. 1 by 6. 100 into 'So this value you are getting 6 megapascals. At the top plus 6 and bottom minus 6 and here is 0. This everybody is going to do it now. So this value will be what now? Plus 6 and here minus 6. So this is due to UDL. Next, assume only this constant at point load. We'll check it if anybody has given now. YouTube 1043, one of favorite sir. Thank you, sir, for your efforts in your online batch student. Thank you. Thank you, my dear friend. So try to share your name now. Next, due to this constant point load, it is the inward. This is the inward. Then this will give a moment in which direction now? Anti-clockwise. And reaction is what now? Clockwise. This is going on the back side. So backside contraction positive. And bending moment is about a positive triangle. This is P. And here bending moment is what now? This is L. And the backside contraction. Then what the BMD here now? And this is HBMD. What the bending moment now? P into L. L value kitna diya tha? 1 diya tha. And what is the bending moment here now? MAH. That is is a positive. Positive means what now? Backside contraction. Backside contraction. And here VBMD means what? Hogging. Hogging means bottom contraction. Then bottom पे compressive मिलेगा, ऊपर में tensile मिलेगा. But here back side पे negative मिलेगा, front side पे tensile मिलेगा. Now once again draw the cross section now. Now this is in which plane? A horizontal plane. And this couple is acting about VCA. So this will be the neutral axis now. In case of horizontal bending, VCA the neutral axis. In horizontal bending, VCA the neutral axis. Vertical bending, HCA the neutral axis. Now this is the neutral axis here now. This is a neutral axis. So any point on this one, what? Stress is 0. Any point on this one, stress is 0. So here, in the previous case, where the stress is 0, JCK. Now here, where the stress is 0, now ECH stress is 0. This is what is given now? E H. At all these points, stress is 0. Now, this will become as what now? Front fiber. We are seeing from the left side. Seeing from the left side, this will become the what now? Front fiber, this is the back side. So this line will become the what now? This is what now? Front fiber. This is back side. This is going like this now, back side contraction. So back side पे आपको negative मिलेगा, front side पे positive मिलेगा. Then once again, how to find out now? Sigma B max M max upon Z. M max is how much now? 3. Z what now? Should be taken about this neutral axis now. So here bending stress is what now? Positive. And here negative. Now to find out the sigma B max now, M by Z. So complete this calculation once again now. So your sigma B max is M max. But the M max value now 3 kilonewton meters. And Z should be taken about neutral. This is a neutral axis. Now what the section modulus about this now? 1 by 6, 200 into 200 square, 200 into 100 square. Simplify this now. This value you are getting 9 you are getting. So here the value is what? The plus 9. And here minus 9. Now which one is the critical point now? F is the critical point. Here F, what the value now? Plus 6. And when F is on the what now? This F is the what now? F is the junction of top and front side. When it is on the F on the top side now, top fiber, it is a plus 6. When F is on the front side, plus 9. So which one is the critical point now? F. So what is the stress at F now? 15. Stress at 15. And what about D? D is what now? When D is on the top fiber, what the value now? Plus 6. When D is on the what now? This is what now? F D, G, H, I. So F is a junction of top and front side. When it is on the top side, plus 6, on the front side, plus 9. So what the value of stress at F now? 15. And what the value of the stress at E? What the value of stress at E? When E is on the top side now, plus 6. When E is on the here top now, 0, because it's a neutral axis now. So what the bending stress at E? Plus 6. And what about D? When D is on the top fiber, plus 6. When D is on the backside fiber, D the junction of top and backside. Top is what? A plus 6. Backside minus 9. So what the value now? Minus 3. Then remaining what now? What about here now? At GCK stress is 0 now. GCK stress is 0 here now. But here G is on the what now? Backside. What the value now? Minus 9. What the resultant stress at J? 0 plus 9, minus 9. So where the stress is 0? Only at the centroid. So bending stress 0 only at C. But what is given in the question now? JCK is incorrect now. When the JCK bending stress 0? Only when vertical bending is there. So in this case, the bending stress will become 0 only at centroid now. And what about K? K the junction of what now? When K is on the what now? Here now. HCA. K is on the HCA. Stress is 0 here now. But here K plus 9. So what the value now? Plus 9 now. Now here I am getting F. Then what about J? Completely opposite will get it now. Here I am getting 15. Then you are getting minus 15. And here how much you are getting now? 6 minus 9. 6 minus 9. Minus 3. Then opposite, diagonally opposite, you are going to get a plus 3. If you want, you can check it now. When I is on the bottom now, minus 6. When I is on the what now? Front side, plus 9. Minus 6 plus 9. Plus 3. Here I am getting minus 3. Here I am getting plus 3. Similarly, G. When G is on the back side, when the G is on the back side, minus 9. When G is on the what now? Bottom side, minus 6. Minus 9, minus 6, minus 15. So which one are the critical point now? F and G. F and G are critical. So what the value now? Plus or minus 15. F you are getting plus 15 and G you are getting minus 15. And what about the bendiment now? Here 4 and 9. 4 and 3. So what the maximum bendiment now? Square root of 4 square plus 3 square. Resultant bendiment at A. And maximum bending stress, maximum resultant bending stress will be at F and G. F is what now? Plus 6 and here what now? Plus 9. Plus 6 plus 15. And what about G? Minus 6 तो मैक्सिमम बेंडिंग स्ट्रेस 15 दिया था, ओनली मैग्नीट्यूड दिया था, बट एफ पे पूछे तो प्लस 15 है, जी पे पूछे तो माइनस 15 है. तो ना विच आंसर सर करेक्ट ना? क्वेश्चन में क्या पूछा था? मैक्सिमम बेंडिंग. फर्स्ट स्टेटमेंट सही है, गलत सही है, करेक्ट है. क्रिटिकल पॉइंट ऑन द क्रॉस सेक्शन एट द फिक्स्ड एंड आर DEF. व्हेन द DEF आर क्रिटिकल ना, ओनली UDL है तो एक क्रिटिकल पॉइंट हो जाएगा. बट हियर क्रिटिकल पॉइंट्स आर व्हाट ना? F and G. And due to constant point node, which one are the critical point? No, these are the critical points now. and maximum bending stress 15. Bending stress at JCK is 0. J is not 0. Here is 0. But here you are getting what? A minus 9. So what the bending stress at J? Minus 9. But the bending stress at C? 0 and 0. 0 and 0. But the bending stress at K? Here 0 and here plus 9. So this statement is incorrect. So answer is what now? A and D. A and D. A and D. Ansari is good. Kumar Anant, good. AD. So critical points are F and G. Critical points are F and G. F and G. So remember what under vertical bending, HCA with the neutral axis. Horizontal bending, VCA will be the neutral axis. So if you ask at E, what the value now? Here stress is what now? Plus 6 and here is 0 because E is lying on the neutral axis. हमेशा neutral axis पे bending stress 0 हो जाएगा. So E is on the top fiber plus 6, E is on the what? Neutral axis here 0. So this is the explanation for question number 12. Quick. So can you give now? We have completed SFD BMD 3 questions I have taken. Now I am coming to the deflection of the beams now. A simply supported beam subjected to a constant point load W at its midspan. Deflection at a cross section located at a distance of L by 4 from the right hand side support. A simply supported beam subjected to constant point load at midspan. Now is asking what is the deflection at a cross section located at a distance of L by 4 from right hand side support पे पूछ रहे हैं. Maximum deflection will be at C, but is asking deflection at D. This is L by 2, L by 4, L by 4. Now you have to find out the deflection at D. Deflection at D. Sir, who is this now? Akash. Sir, enrolled in online batch 2027. I joined late due to financial problem. But basic thermodynamics 17 lectures are over. How I can cover now? So that lectures will be what now? Repeated now. That lectures will be repeated at the end now. Mostly as per my expectation, those you are joined little bit late for 2027, that lecture will be repeated at the end. Meanwhile, they may provide the recorded lectures will be provided for you now. Meanwhile, they will provide the recorded lectures. But the end, like this, what so many students are missed the initial lectures. For them, all the late joined students, they are going to conduct the separate class at the end. But meanwhile, they are going to give the recorded lectures will be given now. Okay. So this question, a question most of the students are going for what now? Macaulay's method. But here for this question, moment area method is the best now. Moment area method is the best now. Somebody can, those who are not thorough with the moment area method, you can also use the Macaulay's method now. You can do it now. But getting the answer is not a criterion. Getting the correct answer within a less time is a criterion. So for this question, those who use the Macaulay's method, they can do it. And somebody who use the moment area method, he can do it. But who is behave like a flywheel now? Who has used the moment area method now? Moment area method. So I'm doing this question with the moment area method. Some students can also try with the Macaulay's method. So what should be the moment area method now? What should be the first step now? Draw the Benjamin diagram. Draw the Benjamin diagram. For this case, you know the Benjamin diagram now. Simply support beam subject to the point load at the midspan. Benjamin diagram is what now? A triangle. Benjamin is maximum at C. A so what is Benjamin value now? WL by 4. Default EA is a constant. Default EA is a constant. So in this case, M by EA diagram is not compulsory. Benjamin diagram is sufficient. So this is you try on your own now. I will also do it. You can compare it now. Because I'm not waiting for your answers because you have to come to the complete some more questions. So I'm doing. Those who are thorough, you try on your own. Finally, compare your answer with my answer. If you are getting the same answer, you are going in the right direction. And obviously, your confidence level increase. But check the method also. Whether your method will take the less time or my method will take the less time. So whichever the method take the less time, that you have to adapt it now. So this is what now? M diagram. M means what now? Benjamin diagram. Here M by EA diagram is optional. M by EA diagram is compulsory when EA is not constant. तो बेंजामिन डायग्राम ड्रा करने के बाद क्या करना है? ऑरिजिन एंड रेफरेंस को आइडेंटिफाई करना है. रेफरेंस पॉइंट. रेफरेंस पॉइंट क्या है? वेयर स्लोप इज जीरो. स्लोप इज जीरो एट द मिड स्पैन. सिमेट्रिक लोडिंग में स्लोप इज जीरो मिड स्पैन. सी. Origin is what now? Non-zero slope. Non-zero slope. Non-zero slope. Slope is zero only at C. Slope is non-zero at A, D, and B. But which one you want to take it now? Where you want to determine the slope and deflection? Question पे D पे पूछ रहे. Here slope is non-zero है. So D is origin. D is a non-zero slope. And see the zero slope now. Reference point is a point of zero slope and origin is a non-zero slope. Now you can highlight the portion of this, highlight this portion now. Highlight this portion now. Then it's का एक बार लेना पड़ेगा. Now what the shape of the diagram? ट्रेपीजियम. आपको ट्रेपीजियम एरिया एंड सेंट्रॉइड मालूम है तो डायरेक्टली का एक बार ले सकते हैं. अदरवाइज स्प्लिट इनटू रेक्टेंगल एंड ट्रायंगल. So this I'm calling as a 1. This is 2. What the betterment here? Now WL upon 8. WL upon 8. So YD minus YC. YD minus YC. equal to 1 by EI into A1 x1 bar plus A2 x2 bar. X बार किधर से मेजर करना है? ऑरिजिन से मेजर करना है. तो YD minus YC is equal to 1 by EI A1 x1 bar plus A2 x2 bar. डिफ्लेक्शन एट D हमने डिटरमाइन करना है. What the deflection at C? Deflection in maximum. What the deflection at C? WL cube by 48A. नेगेटिव है, डाउनवर्ड है. तो इन प्लस ऑफ वाई से क्या सब्स्टिट्यूट करना है? माइनस WL cube by 48EI. Then EI. One by EI. What the area of this rectangle? And इसका सेंट्रॉइड किधर से मेजर करना? ऑरिजिन से मेजर करना है. This is x1 bar. L by 8. This is the x1 bar. Next, this area. For this triangle area, 1 by 2. Its height is also about a WL by 8. Next. And it's a centroid. Once again, you measure from what now? This is the x2 bar. X2 bar. What the x2 bar now? 2/3 of L. But what the L value now? L by 4. 2/3 of L by 2. 2/3 of L by 2. 2/3 of L by 4. So it is L by 6. That's all. Simplify, you'll get the answer now. WL cube upon EI. See 84. So this is 16. So what do they complete this calculation? So this is one is 256. First one is 256. Then this value you are getting for the meaning of minus, not downward. The answer for the question is A. Answer is A. Infinity is given the answer now. A. Somebody is given A and D, both. Same thing can complete the slope calculation also. So for this question, moment area method is the best. No, moment area method is the best now. Somebody can also try with the Macaulay's method. You can get the same answer. but it will take some time now. So this is the best for this question now. So selection of the right method is important now. Selection of the right method is important. Minus means what? A downward. Always remember now, x bar should be measured from origin. Here origin is what now? D. Origin is what now? D. D से measure करना है. This is the x1 bar, this is the x2 bar. x2 bar, how much you are getting now? L by 6. L by 6. So this is one question. So this question, once again from the deflection of the beam. A propped cantilever beam loaded with a what now? UVL. UVL. So now for this one, complete it now. But generally this type of questions are given in the gate examination. What now? UDL is given. UDL or UVL. But this is what now? Trapezium shape now. Load intensity is varying from minimum to maximum. So it is equivalent to one UDL and one UVL. One UDL and one UVL. So now to what the questions are asking now? Support reaction. Location of zero shear force from the. So this question will include the what now? Deflections, SFD, BMD. All are required in this now. Which of the following statements are correct for the propped cantilever beam? This is what now? And next one is what now? This intensity is what now? This 10 I am calling as W now. Is 10 को मैंने W मान रहे. Next, this is what now? UVL. And this total is 2WA. This already W means this is what now? W. That's all. And here one vertical reaction will be there now. Vertical reaction. Now you can use the compatibility equation now. Deflection due to UDL, deflection due to UVL at the B, and deflection due to RB equal to 0, then you will get the RB value now. Deflection at B due to this RB upward positive. RB L cube. This I am taking as L meters. L meters. RB L cube. And due to UDL downward, WL to the power of 4 upon 8 EI. Due to UVL. So from this one, you can find out the RB. From this one, you can find out the RB value. the RB value are getting positive, means assumed direction is correct now. I'm getting a positive, means upward. Now I can substitute the value now. W is 10, L is what now? 1. Now I can substitute it. So this value are getting 4.75, you are getting now 4.75. So complete the vote now. This is 4.75. How to find out the RAV, total load? What the total load now? This total load is what now? 10. This total load is 10 and this total load is what now? 5. Total downward load is 15. Already this is 4.75 and this reaction is by using sigma V equal to 0. Then you can find out the moment reaction. The moment reaction, you are going to get it. Moment reaction by using sigma M. The moment reaction, you are getting 1.92. RBV is correct. This is RAV. RAV. This is also correct. But moment reaction direction गलत है. This is सही है. But इसका direction गलत है. We are getting anti-clockwise, but it's given as a clockwise. So this reaction is incorrect now. So next, you can complete this now. So this I am not doing the calculation. Location of zero shear force. How to get the location of zero shear force now? Take a section, write down the shear force equation and equate it to 0 now. Location of zero shear force. Take a section from the prop. Write down the shear force equation equate to 0. Next, asking the maximum bending moment. Next, point of counterflexion. How to get the point of counterflexion now? Equate the bending moment equation to 0. Equate the bending moment equation to 0. Then in this case, so this statement is galat hai. Check it. This is from pre and prop से मिलेगा. But question पे क्या दिया था? Fixed range पे दिया था. This statement is गलत है. This statement is सही when prop से measure करे तो, B से measure करे तो, because we are measuring the X from the B. So next, maximum bending moment. This is correct now. The maximum bending moment. This statement is correct now. Next, location of point of counterflexion 0.753 meter from the prop. So this statement, you can check it. Correct. So this statement is correct now. The answers are what now? C and D. I completed only RB. Reactions I completed now. Why first statement is galat hai? Iska direction galat diya tha. And why B is incorrect now? How to get this now? Equate the shear force equation to 0. Take a section, write down the shear force equation equal to 0. But you are getting this value from the prop, but it's given a fixed end. Then maximum bending, this is a maximum bending moment hai. Then how to get a point of counterflexion? Bending moment equation ko equate it to 0. That is correct hai. So answers are C and D. The remaining you can complete it now. Anybody has given? You will check it. C and D. Good. McRock is given. Suyaj, try. Two friends have given the correct answer now. So can anybody give the answer for this now? For the cantilever beam as shown in the figure. Cantilever beam as shown in the figure, deflection at B. Deflection at B. Deflection at B. it is loaded by two UDL in the opposite direction. A to B upward UDL, B to C downward UDL. And a constant point load. This is the small correction. This is capital W. Some printing mistakes are there. Capital W by 2. And small w value कितना दिया था? Capital W by L. This is capital W by L. UDL intensity small w दिया था, but that is equal to capital W by L and a constant point load of W by 2 and total length is L. So this is L by 2. Now is asking deflection at B. Directly deflection at B. Either which one is the best method? No, superposition. First, due to constant point load, what the deflection? No, W L cube upon 3 EI. Next, due to this UDL, downward UDL, deflection upward, W L cube upon 6 EI. So deflection at B due to this downward UDL मालूम है, due to constant point load भी मालूम है, but we don't know the deflection due to this one at B. Then what do you have to do it now? This load is equal to how many loads at B? This load is equal to how many loads at B? What the total load of this now? I want the deflection at B due to this downward UDL. What the total load of this UDL? What the total load of this UDL? Small w into L by 2. Small w into L by 2. That is what now? Capital W by 2. This is and this is L by 4. First convert this UDL into constant point load. What the total load? Now W by 2. Small w into L by 2. But small w equal to how much is given now? Capital W upon L. So this total load is W by 2 and L by 4. So this load is equal to how many loads at B? This load is equal to how many loads at B? A constant point load downward and a couple in clockwise. So overall what now? This is small w equal to a constant point load W by 2. And what about this downward UDL is equal to how many loads here? Now a constant point load. And what is the moment due to this? Now W by 2 into L by 4 clockwise. W by 2 into L by 4 clockwise. If we don't use this approach, it will take more time now. Sir, Why you are not converted to constant and point load? Already due to this UDL is a deflection मालूम है. Due to this upward UDL at B पे मालूम नहीं है. So what the deflection at B due to this down upward UDL? W L cube upon 6EI. In place of L, what you have to put in L by 2. So what about the net load? Now this W by 2, this W by 2. Net load is becoming 0. Downward W by 2, upward net constant point load is 0. So now a couple is there now. Okay, I don't know. Due to this UDL upward deflection. What the deflection at B now? W L cube, small W L cube upon small W L to the power of 4 upon 8 EI. In place of L, what should I put it now? L by 2. And what the deflection due to the ML square by 2 EI. ML square by, in place of M, W L by 8. In place of L, L by 2. So what the deflection at B now? YB1 upward deflection positive 8 EI and due to moment downward deflection M ML square by ML square by. Now substitute and simplify. In place of small w, write down the W by L. And this value you are getting. This value you are getting. Check it. Minus what the meaning of minus? Now downward. So answer is going to be A. Similarly, you can complete the what now slope rate also you can calculate it now. Check it, we'll see how many have done it now. So this question till now no student has done it now. Some students will extend it what now, extend this, that will take the more time now. Due to this upward UDL, B पे deflection मालूम है. Due to constant point load also मालूम है. But due to this downward UDL at B पे मालूम नहीं है. So convert into total load. Total load is what a constant point load W by 2. So this will be equal to a constant point load downward and a bendment is what a clockwise. Clockwise. Answer is A. Anirudh is given now. If you use any other method, it will take the more time now. So standard formulas and wherever required, use the shortcut methods now. Wherever required, use the shortcut methods now. So answer for this question is going to be A. W L cube upon 128 EI. I'll come for the next question now. Once again, what are the concept oriented now? If anybody can give the correct answer for this question now, they are thorough with their basics now. figure shows the cross section of horizontal prismatic rod at the free end. This is about now cross section of horizontal prismatic bar at the free end. Free end पे दिया था. At point P, what are the non-zero stress components? What are the non-zero stress components? Now this is Z दिया था. HCA को Z दिया था. VCA को X दिया था. HCA it is given as what now Z. VCA को X दिया था. And obviously this will be which axis now? Obviously this is a polar axis now. Polar axis which axis now? Y. This is Z. HCA is given Z, VCA is given what now? X, and polar axis is given Y now. Now it is loaded by what now? Two horizontal transfer shear load at the top now. Horizontal eccentric transfer shear load 10 kilonewton towards left side and 10 kilonewton towards side. Now these two will form a twisting couple. Now what about this now? Cross. So here on VCA, which load is applied now? ETSL is applied. On HCA, this is what now? Eccentric axial compressive load. Cross means inward. So this is loaded by what now? ETSL and EAL. This is what horizontal ETSL. So these two will form a twisting couple in anti-clockwise direction. And this eccentric axial compressive load inward. This eccentric axial compressive load outward. Now these two will form a what now? Bending couple. These two will form a bending couple. So one is what now? Left side is inward, right side outward. Now these two will form a bending couple in horizontal plane. They are forming a bending couple in horizontal plane. Means about which axis now? PCA. So which is the neutral axis now? VCA the neutral axis. And this point is given on the VCA. So your bending stress 0. So at point P पे क्या मिलेगा? एक ही torsional shear stress मिलेगा. Anybody has given the answer? We'll check it now. For this question, everybody is given A. That is the incorrect now. That only mentioned now. That's why I mentioned this is the concept oriented now. It is subjected to a twisting couple. Due to twisting couple से आपको torsional shear stress मिलेगा. How to find out the torsional shear stress here now? Tau T max into small r by capital R. But what the torsional shear stress now? Tau, first subscript is about the phase, direction. What the torsional shear stress here now? This is torsional shear stress. First क्या लिखना है? Phase लिखना है. Which phase it is now? Y. Which direction? Z. At point P पे torsional shear tau YZ and complementary shear stress मिलेगा. Tau ZY मिलेगा. But everybody is going to take the bending stress. But bending stress 0 here na. Bending stress 0. Sir, क्यों? This point P is lying on the neutral axis. This is not the neutral axis now. Just now I mentioned now. HCA will be the neutral axis and the vertical bending. PCA will be the neutral axis under horizontal bending. So this inward, this outward, they are forming a couple in what now? Horizontal plane. इसके लिए कौन सी axis perpendicular X है? So the bending couple acting about X है. So X will be the neutral axis. So here bending stress 0. By chance this point is given here now. A P is here the end. When the P is given on the HCA, then answer is what now? Delhi. So for this question, answer is because at point P, bending stress is 0 because it lies on tau yz and tau zy equal to tau t. So non-zero are only two, that are what tau yz and tau zy. So this is how to calculate this now. Suppose by chance the point is given here now. If you ask at Q, now this is not the neutral axis now. This is not the neutral axis. Therefore, here you are going to get a bending stress will be there now, and torsional shear stress is there. So if you ask, so with respect to point P, answer is Bombay, and with respect to Q, which is the answer now? With respect to Q, the answer. So at point P, answer is what now? Bombay. At Q, bending stress is non-zero. And what about the torsional shear stress now? This will be in which direction now? Tau. Then answer is A is correct now. Tau yx. So with respect to Q, with respect to Q, A is the answer. But in the question is asking at P, the answer for the question is going to be B. But if the point is given at Q, here if you ask at Q, Q is on HCA, then answer will be what now? A is correct now. Answer is A is correct now. So you should be careful now. Sir, when the option D will apply in this question alternately? Option D is not possible here now. Option D, when it is possible now? When option D is correct now, if this eccentric axial loads are given on VCA, if the eccentric axial loads are given on VCA, suppose eccentric axial loads are given here now. If the eccentric axial loads are given on VCA, then this will be the neutral axis. This is a neutral axis. Then here bending stress is not zero. Bending stress is not zero. Then answer is what? A Delhi now. So this will be correct when now? This is correct. When EAL lies on EAL lies on VCA. I hope your doubt is clear, Mr. Priyansh Raj. So this question, complete it now. For the bar as shown in figure, which of the following statements are true? Which of the following statements are true? Similar question, we have done it in the class also, but I made it into MSQ. I made this question into MSQ. It twisting couple applied. and a uniformly distributed torque is given now. Uniformly distributed torque. Now you have to find out the angle of twist at free end, resilience of the bar on extreme ends of horizontal diameter fiber. This is a horizontal diameter fiber. Horizontal diameter is the vertical diameter. On this one is asking the what the tau xz and is asking tau yz on this now. So complete this question. I will go for the next question. I will give the answer for this now. So those who are not getting the answers, you can contact me. You are already having my WhatsApp number. So for this question, answer is A and D. For this question, answer is A and D. Why B is incorrect now? B is incorrect because of what now? This constant is what now? Energy will be 56 by 81. If this is given, option B is correct, but the constant is given 61 by 18. Complete this now. So this is now you are coming to the principal stress chapter now. For the state of stress as shown in figure, resultant stress on the oblique plane. So on this oblique plane is asking the resultant stress. Theta value nahi diya tha. Theta value nahi diya tha. Most of the students are going to mention, but those who are not attended my lectures now, there are insufficient data, sir. Theta nahi diya tha. How to find out a resultant stress? But here directly can give it now. Is a pure shear state of stress. Pure shear state of stress. Sigma x plus sigma y 0. But the sigma x now minus 100. Sigma y 100 है. कभी भी sigma x plus sigma y 0 हो जाए तो pure shear state of stress बोलेंगे. And a pure shear state of stress. Sigma 1, sigma 2, in plane tau max, absolute tau max, tau s star, resultant stress on any plane equal to radius of the Morse circle. So here, this conclusion already discussed now. When sigma x plus sigma y is 0, sigma 1, sigma 2, tau max, tau s star. But the tau s star, shear stress on planes of pure shear stress, equal to resultant stress on any plane, which is equal to radius of the Morse circle. What the radius equation now? I framed the questions in such a way that what now? All the conclusions are going to be covered now. These are all you have discussed now. So here sigma x plus sigma y 0. So directly what to find out the resultant stress is equal to radius 1 by 2 this is what now? Minus 100 4 tau x y square 50 square, and this value you are getting good. Somebody is already given 111. So this itself we can call the sigma 1, sigma 2, tau max, all are same. So answer for the question is 111 point 111.803. Sir, I'm Bhopal batch. I don't have your contact number. So explain, sir, that question number 17. This already is what now? If you have solved the made the workbook question now, your Bhopal batch means what now? This question is already there in the workbook now. I'll give my contact number 93 at the end. I'm going to give my contact number now. Now question number 19. Question number 19. 1 meter long shaft with a diameter of 80 mm carries flywheel weighing 5 kilonewton at its midspan, and it transmits 40 kilowatts at a speed of 360 rpm. The maximum tensile stress at the horizontal diameter of the cross section at the midspan. The shaft is what now? Carrying a flywheel exactly at the midspan and is transmitting a power. I is asking for the maximum tensile stress at the horizontal diameter of the cross section. This value is what now? And it's transmitting power. Power of how much now? 40 kilowatts at 360 rpm. At 360 rpm. Now is asking what now? At this cross section, shafts are generally what? A circular. The cross section at midspan. Now is asking what now? What is the maximum tensile stress at the ends? Here is asking now. At this end is asking for the maximum tensile stress. Can you give the answer for this question now? ये vertical bending हो गया. Under vertical bending to the neutral axis, then bending stress is 0. So you are going to get only torsional shear stress. Only torsional shear stress. Means this point P and Q are under pure shear state of stress. Just now you have studied now. If it is going to do the what now? Sir, इससे आपको bending stress मिलेगा, इससे torsional shear stress मिलेगा. But is asking at P and Q. P and Q are lies on neutral axis. Neutral axis में bending stress 0 है. And here torsional shear stress maximum है. तो P and Q पे एक ही torsional shear stress मिलेगा. तो sigma x 0, sigma y 0, only tau x y है. ये completely once again concept now. But if it's given the P and Q on here now, then bendings is also there. Then principal stress chapter concept is required now. At P and Q. At P and Q. At P and Q. Bending stress is 0. And torsional shear stress is maximum. So the pure shear state of stress, just now you have studied now, that is sigma x 0, sigma y 0. Whenever sigma x plus sigma y 0, what you have studied now? In the previous question you have studied now. When sigma x plus sigma y 0 is the maximum tensile, the maximum compressive, tau max, all are equal now. All are equal. So you can find out this value. How to find out the torque now? Power into 60 by 2 pi m. Torque is given, RPM is given. Now you are getting this value will be 10.54 megapascals. So the pure shear state of stress, that P and Q. Maximum tensile stress, maximum compressive stress equal to answer directly A. But most of the students, what they will do it now? They will calculate the bending stress, then they will find out the principal stress, then they will do it now. That all the calculations are required if we ask on BCA, on this fiber. If we ask this P and Q here now, then bending stress 0. But here bending stress is what now? 0. Here bending stress non-zero. So answer for the question is going to be A. Answer is A. Good. Priyansh Raj is given A. Good. A. India. Who is that now? India I batch. But that Priyansh Raj you are given now. Good. You are from which batch? HR Gallery Center. Okay. So we'll come for the last question. So still, actually I framed that 25 questions. So 5 questions. I'm going to display it. You can complete this because already it's the 9:45. We'll discuss the one last question. So this you can complete it now. I'll give the answer for this question. You can complete it. I'll also give them my contact number. And if you have any doubts, if you are not getting the answer, you can contact me now. So for this question, question number 20, answer is C. Mohr circle question now. Area of the Mohr circle is asking now. The area of largest Mohr circle for this state of stress. What do you have to do it now? Find out the principal stress. Find out the principal stress. Here दोनों principal stress like in nature है. दोनों principal stress like in nature है. Then which the largest Mohr circle now? Sigma 1, sigma 3 circle. So sigma 1 and sigma 2 like in nature है. So what the largest diameter now? Sigma 1. Largest diameter is what? A sigma 1. Then find out the area. Area is what? A pi d square by 4. In place of d, what you have to substitute it now? Sigma 1. And convert the scale is given a 1 centimeter equal to 20 megapascal. But most of the students are taking diameter means what? A sigma 1 minus sigma 2. Largest diameter पूछ रहे 3 more circle मिलेगा. But here sigma 1 and sigma 2 are like in nature. When the like in nature, sigma 1, sigma 3 circle largest now. Its diameter is what? A sigma 1. So in place of D, आपने sigma 1 substitute करना है. So this you can complete it. ETSL. ETSL. So we'll do the one question on the pressure vessel. Can you do this now? Most of the students are going to do the mistake now. The previous question, I will give the answer. For previous question, question number 21. Question number 21 answer is 64.646 mm. Now this is the pressure vessel. In cylindrical pressure vessel, efficiencies are given now. Now is asking what now? Minimum safe thickness of the shell. Minimum safe thickness of the shell. So first find out the hoop stress. PD by 2T. Efficiency of longitudinal joint. Hoop stress is developed due to bursting of the pressure vessel longitudinally. Pressure has given, diameter is given. Now thickness unknown. Efficiency of longitudinal joint, how much is given now? 0.75. So this is 5. Diameter is 500. And thickness unknown. This value you are getting 1. Most of the students, what they will take it now? Longitudinal stress half of the hoop stress. It's not correct now. When the longitudinal stress half of the hoop stress, when efficiencies are 100% now, here efficiencies are given now. So longitudinal stress is not the half of the hoop stress. Longitudinal stress is equal to PD by 40. That is half of the hoop stress when efficiency are 100%. So longitudinal stress is PD by LJ means longitudinal, CJ means circumferential joint. Now complete all the in place of 0.75, 0.35, and this value you are getting 1785. Now this will become as a sigma 2 here now. Sigma 1. And is asking what the minimum safe thickness. Means you have to go for MDET. You have to go for MDET. So by using the MDET, what the MDET equation now? Sigma 1 square plus sigma 2 square sigma T permissible. Sigma T permissible is how much now? SYT upon N. And some students are using the strength criterion. But when should I the strength? If you want to get the maximum safe thickness now, but in the question minimum safe thickness puch rahe. So you have to go for MDET. I can substitute the sigma 1, sigma 2, SYT 200, factor of safety 2. So from this one, you will get the thickness is what now? Greater than or equal to 17. So some students are going to the strength criterion. So you have to go for MDET is compulsory now. Most of the students, they are going to write down this value, half of this value now. Longitudinal stress is the half of the hoop stress when efficiency are 100%. Efficients are 100%, but here efficients are given now. So for this question, answer is going to be Delhi. Answer is Delhi. So 3 questions I'm showing. Columns question. All the chapters I covered it. Column is subjected to eccentric axial compressive load, 2 eccentricities. Solve this question now. For this question, answer is 0. For this question, answer is 0. Solve this question. If you are not getting, you can contact me on my WhatsApp number now. Next, this is very important now. Once again, this is a principal stress chapter. This is a very, very important principal stress chapter. Most of the students are going to make a mistake now. This is a very, very important now. All the concepts are included in this now. Most of the students are going to give the correct answer A, but they are going to make a mistake in the C. C and D, they are going to make a mistake now. C and D, they are going to make a mistake. For this question, answers are A, B, D. So most of the questions are taken MSQ so that all the concepts are included. This will include all the concepts now. Especially what now? Most of the students, सभी स्टूडेंट में ऑप्शन सी को गलत करेंगे. They don't know how to calculate the C also. Answer no. So this will be for this question. Answer is for C 57 point. For this question, answer is C. Answer is what? 57.168. But it's given 32 points. That's why this statement is galat hai. And this question, last question, everybody is going to do it from the first chapter now. A rigid block. This type of questions you are done in the first chapter now. A rigid block of weight. Its weight is W now. Length is 4 meters, supported by 2 wires, aluminum and steel wires now. And if the block should remain horizontal, the series, if the block should remain horizontal, mean what the meaning now? Both the wires should be equally elongated. So change in length of this aluminum wire and change in length of the steel wire should be same now. So this is what the bars in parallel. So by equating the change in length, we'll get the ratio of the areas. For this question, answer is going to be 2. For this question, answer is going to be 2. So those you are already having my contact number. Almost all the questions are discussed. 2 or 3 questions are not discussed because already the almost 950 is there now. If you have any doubt, you can contact me on this number. This is my WhatsApp number 93477666909. So my suggestion is this subject is very, very important for the GATE. First, if you want to revise now, try to go through my QRC, Quick Revision course. Then solve all these questions on your own now. Some friends are already done it. Who has not done it? So try to solve the questions on your own. Compare your answer with my answers. Then go for the what now? OTS now. OTS FSTs, try to complete it now. If any of your answers are incorrect, don't bother now. Definitely you are going to get a success. Believe yourself, believe the made easy, and believe the teachers, and try to struggle the last 2 weeks time now. 2 to 3 weeks time. Try to utilize this time properly. So most of the faculty already given your suggestions for the exam that I am not discussing. So believe yourself, focus on the concepts now. So thank you one and all. You are the best. Believe yourself. Try to do the right action at the right time. So thank you one and all. God bless you. Wish you all the best. Any doubts? Quick. If you have any doubts, we'll discuss. Otherwise, we'll close it now. I've already given my contact number. If you have any doubts, most of the questions are discussed. One of the Bhopal student is mentioning, sir, I'm having a doubt. Solve this question. If you have any doubt, I will given the answer. Then you can contact me on this number now. Since the weightage is more, that's why I spent almost 3 or 45 minutes. I spent it for this now. So I'm closing the session. Thank you one and all. Good night. All the best.